So a user in my Discord shared this. Jacob says, hello, saw the most recent video with a call to share script, so I decided to show my attempt at implementing a GOTO statement using bash. So far I've got a way to seek forward into the script with an attempt at making it seek backwards as well, but that one isn't as good since it wipes unexported variables and creates subshells. Hope it sparks some interest. Be warned that putting the GOTO inside of a condition or a loop still makes the loop finish, and putting a label inside of a condition or a loop will throw a syntax error. And I said it was disgusting because it is disgusting, but I asked Jacob if I could show this off in a video, and Jacob said, yeah, so here we are. I want to dive into this because it is gross. You should not be doing this. This is for educational purposes only. We are experts, okay? Over here at the You Suck at Programming channel, we are experts when it comes to bash, so we can do whatever we want. But guys, don't do this. This is just meant to be a fun, stupid video. And I think at the end, I'm going to take my attempt at trying to implement GOTO and bash. You should never use this. Do not use this. If I catch you using this in production, I will ban you from the internet. This is my disclaimer. This software is unfit for any sort of use at all whatsoever. But I'm going to see. I've had some ideas poking around in the back of my head on like how I would implement GOTO, and I think I have a way to kind of do it, but it's going to have some issues. So we'll see. We'll see how it stacks up against Jacob's solution. So yeah, let's jump into it. So I got the scripts right here. They're running on a Linux machine. The reason for that is I looked through the scripts a little bit and I saw they were using the proc file system. So we are going to need Linux to make it work here. But yeah, I say let's jump into it. The simpler one is the bash GOTO forward. And this seems pretty simple here. All right, you put a space between here and your shebang. I don't do that, but if that's your style, hey, totally fine. You echo line 1. Then you set a variable called GOTO of #label1. Then you go into a while loop here. So this is the condition of the while loop. I'm going to break this apart just so it's easier to read for anyone watching. But this is what this while loop basically looks like. So while, and then these curly braces create a command grouping. So while you read from file descriptor 255. Now, I have a video where I talk about file descriptors and I demystify them. Go check it out. It's super fun. But in that video, we talk about file descriptor 255. This is special to bash. Bash has its source code here. So you are fast forwarding the bash source code. You are having bash move its source code pointer. Think of it like its instruction pointer forward. Does it actually work like that? I don't really know. I wouldn't rely on this. So like I said, we're experts here, right? And experts love saying, I don't know what's going to happen. So here you go. You read, you don't give read a variable name, so it'll use the all caps reply variable here. While reply is not equal to GOTO. Very, very interesting mix of syntax. I would probably just do like a not equal here, but hey, whatever. That's your style. That's cool. So we read 255, we go forward. Notice that this is an infinite loop here. So like if we weren't fast forwarding the bash source code, we would kind of get stuck here. So notice what's happening here. We're reading one line because by default read will read one line at a time. We're reading one line. If the line, the entire line that we've read has not equal to what this variable is set to, this variable is set to this string exactly, then we fast forward. Now this string exactly shows up right here. So if this works, let's try to logic our way through it. We're going to echo line 1. We're going to run this, which doesn't do any echoing. There is an echo line 2 here. It should not run. We should see line 1 and we should see line 3 if we have read this correctly. So let's go ahead and see what happens there. Oh, I modified the source code. So let's look at the source code like this, and then let's actually run it. Go to forward.sh. So it works. That is insane. That is an insane solution. I don't know if bash ever makes any promises that it's always going to be FD255. In fact, it can change. As this user actually noted in the Discord, things get really weird if you start closing 255 and then it reopens it, but then it doesn't actually read from the thing and reopen it. It's a mess. It's an absolute mess there. I probably shouldn't be closing it, guys. But this is crazy. That's actually really cute. I like this. This is really a clever solution. Now, of course, this raises the question. So you're able to jump us forward. How do we go back? Because this relies on us being able to read our own source code. In fact, actually, you know what? I'm curious now. What if we were to cat bash GOTO forward and pipe it into bash? I see. We don't have access to the 255 variable in the same way. So let's just go ahead and say that's not going to work. How could that work? Because it can't really access its own source code. Well, it should be open up somewhere. It would be... Hold on. Would you be able to do it as standard in, or am I overcomplicating this? Or am I not complicating this enough? Hold on. If I do this, if I change it to 0 for standard in. Okay, that works. If the bytes are coming here, then we can check it. That is certainly something. So could we detect this at runtime actually? I think there's definitely some ways to detect this at runtime. Could we check if 255 is valid? Let me think. If we did if exec into 255, does this work? Let's just try this. And then we'll throw an exit here. So this script is just going to do this top part. We're going to see if the syntax works that I just made up. So we got false there because it's a bad file descriptor. But if we do bash GOTO forward, we get a file descriptor on line 4. Interesting. Can we do this? Read into a throwaway variable and read in from 255 like this. So we're going to duplicate the file descriptor, but it shouldn't matter. We're duplicating into a throwaway variable. I'm just making up syntax here. Okay, so that's true. And then if we cat this, we get false. So that's huge. Now, we do have some error messages here. Who cares? No big deal. Because if there's just error messages here, we can throw them out. Will that throw all of them out? No, it won't. Interesting. But who cares, all right? We're just not going to look at the error messages, okay? So we can do this. If we can read from 255, the FD is 255. Otherwise, the FD is 0. Probably a cleaner way to do this. Oh my god, could you just dupe over 0 with 255? This is meant to be a small, stupid video. Why am I super overcomplicating it? I know why. It's because you guys like to watch me overcomplicate things. So if we do this, this should work, right? Let's cat it into bash. We get some errors. Ignore those errors. Line 1 to line 3. Hey, that's something. Bash GOTO forward. Well, we broke it. Oh, wait, does this not work? Are we doing something weird here? Hold on. We might just not be throwing away errors. We might be doing something very odd there. That's what was happening. Okay, we were doing something weird. Yo, it works. We get some stupid errors that we're not really hiding. I mean, I guess I could do this. Assuming they're going to standard error. Hey, we just hide all the errors. But yeah, that is certainly something. So yeah, what a mess. Guys, don't do this. This is just meant to be fun, okay? Let's take a look at how you implement GOTO backwards. Oh boy. Okay. Beautiful. Let's go ahead and clean up just some stray white space you have here. And let's kind of acquaint ourselves with what's going on here. We are going to be doing GOTO, so there's going to be some jumping backwards. So things are going to be a little bit out of order here. Not a big deal. Let's just figure it out. If GOTO is a variable, so that's what we're looking at here. So if GOTO is a variable, then we will start doing the GOTO process, basically. So let's ignore that for now. So we echo line 1. Then we create a label for 1. Then we echo line 2. Then we check if there's a variable called I. Okay, so we do have another environment variable. We're sneaking in here. If I is set, then we do some stuff here. So let's ignore that for now. There's no I. There's no GOTO yet. We echo line 1. We echo line 2. We echo line 3. We set var1 equals hello. Then if I is not set, which is where we are, we're logicking our way through this. Then we set I equal to 0 as an environment variable. We set GOTO equals to this. And then we exit. Now look at what's happening here. This is a very interesting trick. We're using some external tools like readlink, and we are using this Linux trick, or any sort of proc file system that has this sort of interface, /proc/ our current PID /fd255. You are calling readlink on this. So you're assuming that the proc file system that we have, this is not a value judgment, I'm just explaining what's happening. You're assuming the proc file system we have has an FD directory. In there, the FD directory will have the number 255, which is our bash script. You're going to call readlink on it, and this will give you our bash script. So you're going to try and re-execute our bash script. We might be able to change this without having to use readlink here, but let's worry about that later. Let's just reason about what we have. So you set GOTO equal to label 1, and then you call the script here. You could also do this, by the way, which would send it as an environment variable without having to call export. But you set GOTO equal to this, and I is equal to 0, and then we go back to the top of the script because we're re-executing the script. Let's go back to the top of the script. If GOTO exists, then we echo going to GOTO. What do we set it to? We set it to label 1. Okay, go back to the top. We're going to go to label 1. And we're going to go forward. Okay, so you're using the same trick here. This is clever. So we can't go backwards, but we can start over and go forwards from there. So I see what's happening here. We loop forward until we get to where we need to go. Then you unset GOTO, and you just let... If you're skipping over the input here, won't you not run this unset GOTO? I don't think this will run. Wouldn't you need something like this? Like set something throwaway, set like a throwaway variable, like foo equals GOTO, like a temp variable. Like temp equals GOTO while temp is not equal to that way. And then you can unset GOTO here. So I think you might want something like that, but let's look at it. So we unset GOTO. I'm not convinced this will run. We go down to the label. So in our example, we're going to go to label 1. So we print 1, 2, 3. Then we go back up. We print going to label 1. Then we're going to print line 2. This will be set. So then we will go to label 2. And then we'll go here. It'll say going to label 2. And then we'll jump down to label 2. We'll print line 4. We'll print this var. And then we'll print line 5. I don't know if the var will be set, because I remember that being one of the issues. Let's quit out of this. No changes made. I guess I just changed the white space. Well, I didn't actually commit those changes. Let's run bash GOTO backwards. Okay. Line 1, line 2, line 3, going to label 1, line 2, going to label 4, or label 2, line 4, line 5. That's what we thought would happen, and this is where you print var. Now notice var isn't set. You mentioned that it would be unset. So that is our output. That is what happens here. That's very clever. I guess, you know what? You unset GOTO here. I don't think this ever runs. I don't think this needs to run, because think about it. Yeah, GOTO is set, but you're never going to get back to the top of the script unless you re-execute yourself, and you're never going to re-execute yourself unless you call GOTO. So you're probably fine, assuming you write everything in order. This could be this, and then, again, this could also be this, and we should get the same output. Yeah, that looks the same to me. So that's just a simple way to clean it up. You do lose var1. You mentioned that would absolutely happen. Let's just clean these up. Yeah, if you wanted to keep it, you would have to do something really gross. You would have to export variables every time you use them. There is a way you can do that. I think set has an option for that. It's like set -a. Mark variables which are modified or created for export. This is, don't do this. We're already in the territory of don't do this, guys, okay? And if you like what you see and you like me doing things with bash you shouldn't be doing, or you like people in my Discord doing that, go ahead and hit the subscribe button, okay? We have 110,000 subscribers at the time of this recording. Let's get more. It'll be a lot of fun. It's the only time I'm going to ask you. That's a lie. I'll ask you at the end of the video. But if we go up here and we set -a, then we will mark all those variables for export. So they will be exported in the environment. So we should get a var printed. And we do. Look at that. Don't do this. The reason you wouldn't want to do this is because your environment is going to grow very large based on every single variable you set. For small things like this, it will work and it's very clever, but yeah. Now here's the interesting thing. You are calling readlink on this. So I'll show people what that looks like. Let's just do that in our own little script, okay? Simple proc readlink. We'll make our own script just to show what actually is happening there. So let's chmod +x, simple proc readlink. Let me vim it again because, yeah. Let's get rid of this. Let's get rid of this. Here is what's happening here. So if we bat simple proc readlink and then we run it, this actually gets the full path of the bash script because this is a symlink. We can prove that. We could do something like before we call readlink, we could just do an ls-lh on it. So we can see that, okay, here it is. It's a symlink. This is the thing, and this is what it points to. So that's what's happening here. You are finding the source code that way. What you could also do is we could avoid a lot of this stuff by just looking at $0. This, you can modify this. There are some ways to break it, but $0 was the name of the program as it was executed by. So without having to use proc or readlink, you can get the same thing. This breaks. This absolutely 100% breaks if we were to do something like cat simple proc readlink and pipe it into bash. Then it suddenly just calls itself bash. That is not great. That is not what we want here. But your backwards example also won't work as written because that 255 FD is just not there. We can't find ourselves. But I would say for this example, it's probably safe to use $0. We could put some checks around this and try and be smart about it. But yeah. So this is what Jacob has. This is it's very clever. I will say that it's very clever. No one asked for this feature. You shouldn't want this feature. And yeah, just don't use it, okay? We've moved past the need for GOTO in our shell scripts, okay? They were implemented in some of the earliest shells. Like I think the Bourne shell actually did have this, but we're talking like the 70s. We're talking like early 80s. Like I don't think it's been in there for 50 years at this point. So let's not do that. But I do want to try my hand at making my own, okay? I want to see if I can do it. because I have some ideas here, okay? So let's do this. We'll call it my GOTO. This is my version, my attempt at implementing GOTO in bash. chmod +x, my GOTO, vim, my GOTO. Now, my trick is that I'm going to use the old style syntax for labels. These used to be around in shells, which is what the colon command was originally for. So we're going to have label 1 here. Actually, let's just call this first. We'll do first, second, and third. So these are our labels. We're going to override the colon command. This is what I think is going to make sense here. So let's echo foo here. Let's echo bar here. Baz here, and bat. Now those colon commands won't do anything, so don't worry. They have no effect. They'll run, but nothing actually gets done with that. It's just a successful command. So if we run my GOTO, we just get foo, bar, baz, bat separated by new lines. There we go. That's what we expect. Now here's the trick I want to exploit. I've showed this before in previous videos. I don't even know if this is going to work, but I think this is going to work. Let's make a function here called debug handler. There we go. This is our debug handler command, and we will trap it to run debug handler when the debug event is fired with bash. This is all built into bash. It's a pseudo signal that bash has where it will run anytime debug is fired. Now debug is fired, I spelled it wrong, but you can see debug is fired a lot. Debug will get fired before any commands are run. So you can see there's a whole bunch of stuff being run here. One for the colon command and one for the echo command. One for the colon command and one for the echo command. That's what's going on here. Now I can prove it because there's also a variable we can interrogate, which is all caps underscore bash command. No, I was wrong. Bash command, it has to be typed out fully. So if we run this now, take a look at this. Okay, we can start to see our bash script taking form here. This is what our bash script is running. Now, why is this important? Because we can make decisions. It's going to sound insane. We can make decisions on whether or not to run the command. I can return an error here, and we won't run the command yet. Hold on. Because if I run this, we still run the command. I can see that we run foo here. We can run echo. We can run echo. So we run echo 4 times. We're still running it. But if we turn on this feature called shop -x, shop -s, I think it's extdebug, because there's ext glob, extdebug, I think is what it is. I could probably double check. I should probably do that. Actually, let's just do this. I think it's this. Yeah, okay. If set as shell invocation or in a shell start file, range to execute the debugger profile before the shell starts, identical to the debugger option. If set after invocation, behavior intended for use by debuggers is enabled. The -f option to declare, cool. If the command run by the debug trap returns a non-zero value, the next command is skipped and not executed. That is huge. This is huge. Wow, if the command run by the debug trap returns a value of 2 and the shell is executing in a subroutine, the shell simulates a call to return. This is really... Okay, I didn't know some of these existed. Interesting. Okay, cool. There's a lot going on here. We only need that one feature, though, where we turned that on. So if we look at it here, we can see, oh, there's a lot of stuff here. But if we run this now, we should see nothing except the debug handlers. Yeah, because none of the commands are being run. So here's a way of going through our script without running commands. Can you kind of see where I'm going with this? At least this is what I think will work. Now what I want, I have to think about what I want here actually. I want a GOTO function. We have our debug function. I want a GOTO function because I want someone to be able to say GOTO. So basically here, we're going to echo foo, we're going to echo bar. Now I want to go to third and have it skip over baz. We'll put an exit 0 here. We'll do an exit 5. We'll just trap that code. And then when we get down here, we can do a go to second. I know this is very confusing, but basically what's happening is we're going to echo foo, we're going to echo bar, we're going to jump down here, we're going to echo bat, so we're going to go out of order, then we're going to jump back up here to baz. So it should be foo, bar, bat, baz, and then we'll exit with a code of 5 if it works how we think it should work. Now, it's not going to because I haven't implemented GOTO, but that's the idea here. So here's what I think is going to happen here. When we call GOTO, what we want to happen is we are going to, we're going to need a state machine, basically. A small state machine, not a big one. We're going to have to export a variable called label. Just export it, make sure it's available as an environment variable. We're not going to set it, we're not going to overwrite it, we're just going to make sure it is marked for exporting. Then down here, we're going to overwrite label to be whatever the user gives us. So GOTO will take an argument. So when we call GOTO down here, it'll be set to the string third. And now that we've done that, we can execute the script again. Now remember how I said there was $0 here? Well, we don't need to fork and exec a new version of this, which is what Jacob's version suffered from. It was actually forking a new process. Every time you called GOTO, you would have a new child process there. What we can do instead is we can call exec here. So we can tell our program to re-exec itself. Now we are losing arguments. If the user called our script with arguments, we're going to lose those, but I'm not worried about that, okay? Because you shouldn't be doing this. This is bad. I don't know if I can stress this enough. This is not something you should be doing in your scripts. You're just watching this because this is fun, okay, guys? We need to implement the logic to move the script forward. So imagine we call GOTO third here. We've re-executed ourselves. We need to run all this code again. We need to run every single line of this code until we find the label we're looking for, which is a command with a colon sign. So we need to skip over everything until we hit that. We need to split apart bash command because it's gonna be colon space the label. We could look for that exactly, or we could split it up. So read -r command and name from bash command. Let's go ahead and mark these as local. Might be a little bit confusing. Actually, yeah, it's gonna be a little bit confusing. I'll show you real quick what I'm doing here. So let's just put this here. Ignore the stuff below this. We're just gonna echo, hello, how are you? And exit 0, okay? That's what we're gonna do, no big deal. And we're gonna just print it to the screen. So if we print this, oh, right. We tried to run exit 0, but it didn't actually run because we returned a failure status code. Let's return a 0 here. Let's stop stopping things from running. It's a little bit confusing, but echo, hello, how are you? Hello, how are you? So this is the whole command. We're gonna get command as hello and how are you will be the rest of the stuff. So we're basically splitting it up based on arguments. That way we can look for a colon command. If the command is colon, so if the user is trying to run the colon command and there is a label set, which was the argument given to the colon command, if they're trying to run the colon command and there's an argument given, then we can put some debug out here. We can say debug, we are at label name. Cool. Let's get rid of this. I feel like that's gonna be too noisy. So if we get here, then we know that we're at the label. We're basically going through the source code, executing it, and trying to find what we're looking for. If the global label exists, meaning that the label was given to us as an environment variable and we are looking for it, if it exists and our label equals the name that we are currently looking at, then we've found it. We have found our label. Then we can set label equal to nothing. Let me think. Yeah, okay. I'm getting there. This is weird. I have to think out of order. GOTOs are so weird. Because now if we're down here, if label is set still, that means we have not found it yet. We need to keep going. And in order to keep going, we return with an error. So we are looking for a label and haven't found it yet. Keep going. That's what we're doing here. Otherwise, allow the command to run. Something's still gonna break here. I just know something's gonna break here. There's still something not right here, but let's go ahead and see if this makes sense. Foo, we're at label first. Bar, we're at label second. No, we're at label. We're at lable. Hold on. Lable. Yeah, that looks super weird to me. Okay. We are at label first. Bar. We are at label second. We are at label third. Bat. Foo bar bat. That's the right order. We just haven't started the script over like we were supposed to. So if we do this. What's the last thing it runs? Exec equals this dash n second. Oh, I see what's happening. We're not allowing this exec command to run. That's what's happening. Oh, I see exactly what's happening here. Yes, we are not allowing the exec command to run because we have that debug thing on. So we need to turn it off. This is not a big deal. This is not a big. We turn it on at the beginning of the script. We can turn it off right before we hit GOTO. Change the S to a U from set to unset, and this should work. We should get foo, bar, bat, baz, and then we should exit with a code of 5. Foo, bar, bat, baz. There we go. That's huge. We have GOTO. Yeah, we have GOTO. Are there limitations? You bet there are. Okay, don't do this. We're losing all the variables you have set because we're re-execing the script. Those are just gone. We could fix that, of course, with the set -a, but you know, that's kind of cheating. We are relying on $0 to be set there, so if you cat the source code into it, it's totally gonna break. Wow, this is a mess. Don't do this. This is so silly. And what else is gonna break? Oh, you know what else breaks? We are looking for the labels. If the labels are tucked inside a conditional, we may never get there. Like, so that doesn't really work. So if you had like, if false, then this, or even if you put it here, it doesn't matter. We're not parsing it that way. So this will actually we'll never see this label. It'll never work. So don't put your labels in conditionals. Don't, bro, I don't know. Don't use this. Don't use this. This is not good code. This was just meant to be a fun, stupid little video. So this is how I would tackle GOTO. Thank you, Jacob, for sending me down this road. This was ridiculous. Hopefully you guys enjoy this style of video. This is just a fun, nice little break. So yeah, a lot of stuff going on there. What a mess, but that's all I got for you. Don't use GOTO in your bash scripts, okay? It's meant to be fun, educational. Let me know what you guys think about these kind of videos that aren't actually useful at all. They're just purely for entertainment. And of course, I can't end a video without thanking my patrons over at Patreon. Thank you so much for your continued support. If you would like your name at the end of one of my videos, go ahead and hit that, I was gonna hit that subscribe button. This is amazing. I love that hey there shows up here. Wait for it, Jordan's got the color output. Hold on. There we go. Incredible, incredible things you guys are doing over at Patreon with your names. This is amazing. So yeah, what did I tell you guys to do? Go get your, sorry, I got mesmerized watching Dark Space name flood in, which is so funny because I've seen it happen a bunch of times, but still, that was amazing. So yeah, go check out the Patreon if you want to sign up there and get your name at the end of one of my videos. Otherwise, just hit the subscribe button. That's all I ask. Thank you, everyone. That's all I got. I'll see you guys later. Have a good one.